So now I want to tell you we are going to solve all the questions and plot the graph. I've created this table, right? So I want to start this lesson from the beginning before I derive this table and do it and plot the graph. Alright. Hello and welcome. Mr. Primus now wants to teach you how to plot graphs. We are going to complete this table. So this is a typical of what you may have. I'm not saying that I'm not saying it's exactly what you're going to have. If anybody tells you that this is what Waec has given students, just make in the comment, this is a lie. None of us, no teacher has seen the answers to the question. All these things that they say, expo, whatever, it is not true. The only thing that teachers can do is to guide you. So I'm here to tell you the truth, nothing but the truth, please. So if you see any video at all, expo or whatever, it is not. What we do is to guide students to make it well, to do it well. So please follow me. If you're able to follow me well, you are going to answer that question very well. Any question that you are given. So what matters is to learn how to do it. If you can do it, then you are already ahead. You are already sure of getting a very good score. So you have performed the experiment following the instructions. Check our previous videos. So you have performed the experiment. If you're able to follow any instruction, follow the instruction of whatever that is given to you, you will definitely get a very good table. So this is a typical table. This is typical of what you may obtain in one of the experiments. So now, the question, after obtaining this by using the setup and other things, after obtaining these figures, the next thing is to do your conversion. The question number 6, other ones are the things that you may have done. Tabulate your read, you have already arranged it. Please, remember to draw this with ruler. Call it table of values. Many students do forget to write this. Always give it a heading, table of values. So if you do it like this, it's complete. Remember to write this, please. Many students don't remember to write this. Then draw this with ruler. Now, we have only two decimal places. After decimal point, you have two numbers like this. But if we have something like inverse, like weight minus 1, it is going to be up to 3 decimal places. I explained this in our last video. So we are using 2 decimal places here. So, but if you are given anything inverse in an experiment, please, your decimal place should be up to what? 3. So these are the figures you may have obtained having performed the experiment. This is not exactly the same, but you may obtain a table like this, be it any practical, whether this year or at any time, anywhere you see yourself. So if you have obtained a table like this, look at what the question says. With your setup, you have obtained figures like this. After each one you recorded, these are the figures you recorded by performing the experiment. The next thing are the things you can do without the apparatus. Now look at this. It says, evaluate P equal to W1 minus W2. Weight 1 minus weight 2, CP. So this is P. Evaluate. Whenever you see evaluate, it means you are creating a column. Evaluate, so you are creating a column. That's why I've already created it. So these are P. It's equal to what? W1 minus W2. And Q. W1 minus W3. Q. W1 minus W3. So we have created the table, the columns now. So it's now time for us to subtract and fill up the table. So now this one will have a derived unit, but it is also in Newton. Remember what I said? There is no deduction of mark for any derived unit. But if you can put the unit, it's still not bad. It's okay. Unit is in Newton. Alright. So let's subtract. I started to do it here with you. So now this means weight 1 minus weight 2 for this our P. So this is this minus this. 0.50 minus 0.43 gives us 0.07. 0.07. Now, the next one is 1.00 minus 0.90 gives us 0.1. Look at what I've obtained here, 0.1. Then I have to complete the decimal places, 0. Can you see it now? If you don't complete it, it means if you leave it like this, as I obtained 0.1 here, if you leave it like this, it's wrong. So complete it, so that you don't lose half mark. Alright, so 1.50 minus 1.30 is at 0.2. So I'll write it 0.20. The next one, 2.00 minus 1.73 is equal to 0.27. Okay, then the next one, 2.50 minus 2.15 gives us 0.35. So now what you are supposed to do is, at the end of this, you have to repeat it to be sure that the figures you obtained are correct. So the figures here, to the best of my ability now, are correct. But after doing something like this, you have to repeat so that you can be sure of the figures you have obtained. Because in my last video, just like I said, you may want to press 2.50 minus 2.15. Then by mistake, you may press 2.5 minus 2.1, something like that. It will give you a wrong figure. So be very careful. Now we have completed this one. We move to the next one. Q, W1 minus W3, this minus this minus this. So 0.50 minus 0.45 gives us 0.05. 0.05. Now the next one, 1.00 minus 0.88. 1.00 minus 0.88 gives us 0.12. 0.12. Next one, 1.50 minus 1.33 gives us 0.17. I decided to do it here, so I hope I'm not taking our time. 2.00 minus 1.75. So I said we are going to plot the graphs. We are going to plot the graphs, this table and the graphs as it is. So after doing this, we are going to plot the graph, find the slope. We are going to solve all these questions, please. Alright, so 1.7, okay, 2.00 minus 1.75 gives us 0.25. Alright, yeah. The last one, 2.50 minus 2.20 gives us 0.30. Okay, now that we have obtained the figures, the next thing to do is to go, continue, tabulate your readings. That is, the question started from I, V, V. Now this is V, now this is VI. So we have done this. We have tabulated our readings. The next thing is to plot graph of Q on the vertical. So let's plot the graph now. So we draw our Q like this on the vertical. Then, so our Q in Newton. Q in Newton, derived. Then P on the horizontal. See the horizontal, horizon. So these are P in Newton as well. Now we check the values you have. On Q, these are Q. What is the highest number here? 0.3. Lowest number is 0.05. This is up to 10. And this is up to 10. This is about 10 or thereabout. So you have to use values that will make your graph to be wide enough. Don't make it a short graph. No. So make it to spread. Alright? So here on Q1, so we have 30, 1, 2, 3, 4, 5, 6. Let me spread it like this. So just plan it very well. Plan it because each one is 10 like this. So you can say each of these is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you look for numbers that when you do it, it will spread enough to give you something that is wide. Alright, so you can even say, give you like this, 20 is the first value, second value, third value, fourth value, fifth value, something like this. You can still do it like this. So we can do it like this, 2, 3, 4, 5, so that at least our graph spreads. So 0.05, 30, so we can use 5. If you're having high numbers like this, you can say 50, 100, 150, 100, 150, 200, 250, it's still wide. Instead of saying 100, 200, 300 is small, you spread it. Instead of using 100, 200, 300, it will give you a very small graph. It's better to say 50, 100, 150, 200, 250. So always plan it like this. It's very, very important, right? So now, but this is not what we are plotting. We are looking at this here. So we now look at this. The highest number is 35. The least number is 0.07. So it's still the same thing. 5, 10. Okay, now let's complete this one. 0.05. This is the 0 mark. So next one will be 0.10, 0.15. If you cannot get these values, always add 0.0 here, 0.05. You write, you press on your calculator 0.05 plus 0.05, it will give you this value. You press it again, 0.10 plus 0.05, it gives you this, plus 0.05, it gives you this. So it's better to use calculator instead of making mistakes. Just be adding the value to the subsequent one. Alright, so this is 0.05, 0.1520, 0.25. Then here I have space Q in Newton, 0.30. So it's almost at the M. So this one is the same thing, 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, 0.35. So we can plot this one like this. I'm not using graph sheet, so you can still get the same values if you do it well. So let's go now. When P is 0.07, so 0.05, here half of it will be 0.75. Half of it will be 0.125. So 0.15, 0.125. So it continues. So you should be able to interpret each of these. If you cannot interpret each of the lines, so divide this by 10. You know what 1 represents. So divide it by 10. Divide it by 10. You know what one of these represents. So just now. So now this is 0.07, 0.075. So we come here. This is 0.07. Here, I'm just doing it like on estimation. This point now. So this is it. Dot, circle dot. When you mark the point, you circle it. The next one, I wish that this would be accurate because we are not using a graph sheet. Alright, the next one, when P is 0.10, there is this point, 0.12 for Q. So you see, this is 10, this is 12.5, this is 12.5, this is 15, so half of it is 12.5. So it's not up to half of it. So you trace it up, like this. This is the point here. This is the point here. So this thing is not supposed to be here like this. Just using it to trace it. Alright. This how. So let's keep it and see if we can get possible 3. Alright, next one is, see, because this is not equal to this, they're not balanced, but let's see how it goes. 0.15. Alright. Next one is 20. 0.20 on P. See it here. And 0.17. See 15, 175, 17 should be here. So we trace it up, trace it up, trace it up. This is it here. Alright. We've gotten it again. Okay. So we continue. Alright, so next one. 0.27, 25, 27 should be here. Not up to half, almost half. And 25 is here. 27 is here. I hope this is straight. Okay. Alright. So this is the value. Then the last one, 0.35, 0.30. 35, 30. Yeah. Okay. Yeah. Like this. To this. Okay. So we can get, now this is the point. Okay. Alright, now we use the ruler. Join three possible straight line. 3. Can get only 3 like this. So we draw it, join them. If we join this, let's join it like this. We join it like this. Okay, can go like this. Okay, let me see. Straight. I'm not using ruler. Straight. Good. But ordinarily, if you have something like this, something like this is supposed to cut from origin like this. Because we are not using graph sheets, so it's something like this. This is better. From origin, okay. This is better. This one is better. Sorry for this. Alright, so this is better. And we have 2 points off. 2 points off. These are the 2 points. Okay, this is okay. So now we can determine our slope. So you use your slope here, bring it down, bring it like this. This is our slope now. And this our slope is changing what? Changing Q. This place is our change in Q, and this is our change in P. So that is the value of our slope. So you can put something like this, put it to balance it. So now the value is, now slope says determine the slope S of the graph. So our slope is what? Change in Q over change in P. That is Q2 minus Q1 over what? P2 minus P1. Alright, so this gives us what is our, this is our Q2 upper value minus lower value. That is 0.25. Allow me to finish it here. So 0.25 minus 0.05 over this upper value is 0.27 minus 0.07. Alright, so if we subtract this, use our calculator. So 0.25 minus 0.05 that is 0.2 divided by 0.27 minus 0.07 will give us also 0.2. This divided by this is 1. This is the value of our slope. So let's repeat this. 0.25 minus 0.05 is 0.2. 0.27 minus 0.07, that is also 0.2. So our slope is what? 1, and this slope of the same values, so there's no unit. So this is what you have obtained now. Then you can go to your precautions, answer other questions. I avoided error due to parallax and other errors that you may have observed. Precautions are not the same in all experiments. So with this now, I hope you have been able to understand what you have to do. Whenever you are given any question, when you are solving it, you should be very, very careful. Put the units, plot your graph, make it very neat, usually where appropriate. So I thank you very much. We are going to do another one that is a bit technical, a bit more technical than this for the other questions. Mr. Primus says, good luck.